So I'm getting the remainder as 0.
So probably the mistake that you might have made is, you see, there is a x cube term, but there isn't any x square term present. So you will have to take into account 0x square over here. Did you take it?
Yes.
Okay, great. Then you are going to divide it by x plus 3. So x times 2x square is going to give you 2x cube. Then plus 6x square, you're going to change the signs. This is going to be 0. This is going to be minus 6x square. Then x times minus 6x is going to give you minus 6x square minus 18x. So this term is going to be cancelled. You are going to get 17x. Then this should be multiplied with plus 17 to get you 17x. 17 times 3 is?
1 for the remainder 1. 17
Yeah,
times 3.
so that's going to be 51.
Yeah.
So when you change the sign, you're going to get 1. So that's your remainder.
Yes.
So in this, if 2x cube minus x plus 52 was being divided by x plus 3, then you are going to get x 2x square minus 6x plus 17 plus 1. That's the remainder. So again, I'm going to call this as my dividend. X plus 3 is going to be called divisor. This is going to be called quotient, and this is going to be called remainder. So as a general rule, if I have a polynomial and a polynomial is divided by, so I can also write this as, if if the polynomial is divided by, let's say, a divisor, d of x is a function of x. Okay, divisor is a function of x, polynomial is also a function of x. So you are going to get a quotient plus a remainder. Now remainder could be a constant number or remainder could be a expression as well. So I'm always writing r of x, meaning I'm treating this as a function as well. Now p of x divided by d of x is same as saying p of x equals to q of x multiplied by d of x plus r of x. See, p of x divided by d of x is equals to q of x plus r of x. This term is going to go and multiply over there. Okay, so something like that. Just a second. So the idea is that the divisor, the polynomial is always equals to the multiplication of the divisor and the quotient, and then you're going to add the remainder to it. So you need to remember this thing, that a polynomial is always equals to quotient time divisor plus the remainder. That is basically the algorithm that is used to solve a polynomial always. Let me know if you have any questions to here.
I'm fine.
Okay. Now we are going to see factor theorem. So if you have a polynomial x cubed plus 2x squared minus 11x plus 6, and you can write, and if you are asked to divide by x minus 2, then you are going to get a quotient x squared plus 4x minus 3. Okay? We saw this in the previous example as well. Now these two terms are basically called factors. You can say, you can call them to be factors. So I know that this is quotient of quotient, this was my divisor and this was my polynomial. Now if you are going to plug in, see, you don't have any remainder over here, right? There is no
Yeah.
remainder. That's why this is going to be called a factor.
Yeah.
So if I am going to plug in 2 over here, 2 in this expression, 2 minus 2 is going to be 0. And
Yeah.
0 multiplied by anything is going to be 0. So the entire right hand side is going to be 0 then. So if in this polynomial, if I'm going to plug in 2, okay, I will have to plug in 2 over here, over here, over here. This is going to give me some answer. So what would you get if you plug in 2 over here? 2 cube
Uh,
plus 2, 2 square minus 11 times 2 plus 6. Can you calculate this?
yeah. So, 0.
0. Yes. So if you plug in the value of 2 in the polynomial, you are going to get 0. This is the indication that x minus 2 was a linear factor. X minus 2 is a factor. So generally you can say that if for a polynomial p of x, if in the polynomial you are going to plug in a value, if you have x minus c as a factor, okay, and if you are going to plug in the value of c in the polynomial, and if that comes out to be 0, then you can say that x minus c is a factor. This is the simple factor theorem. So if I want to test whether x minus 2 is a factor or not, I'm going to take x equals to 2 and I'm going to plug it in the polynomial. If the polynomial results in 0, then x minus 2 is a factor. If it gives me a value other than 0, then it's not a factor, and the value that I'm going to get is going to be the remainder, and that I'm going to teach you in the remainder theorem.
Okay.
Any questions till here?
No, sir.
Okay. Now, if you have a polynomial, let's say, if for a polynomial p of x, and let's say you have a linear factor as ax in the form of ax minus b. So, if ax minus b is a, if you want to check whether ax minus b is a factor or not, you are going to equate ax minus b to 0 and get the value of x. So you are going to get x equals to b upon a. And if in the polynomial you are going to plug in b upon a and you get the answer as 0, then ax
Right.
minus b is a factor. So for example, if you are asked to check, verify that 3x minus 2 is a factor of 3x cube minus 2x square minus 3x plus 2. So what is the first thing that you are going to do?
3x minus 2 equals to 0.
Yes.
Then you get 2 upon 3, and then you plug it in.
So in the polynomial, that was 3x cube minus 2x square minus 3x plus 2. You are going to plug in 2 upon 3 over here.
Yeah. I'm just doing
And this should come out to be 0. Okay.
it. Okay. Yeah, it's 0.
All right. Use the factor theorem to show that x minus 3 is a factor of x cubed plus 2x squared minus 16x plus 3. So you know what to do, right? You can just try this
Yeah.
question out. I'm going to write the other questions for you. So you might be done with the first, right?
Yeah, so I'm done with the first.
Okay. So as far as the second is concerned, you have been given that 3x squared plus 5x minus 2 is a factor. Now you see it's not a linear factor, it's a quadratic factor. And the quadratic factor is gonna divide your cubic polynomial. Okay?
Mm,
So
okay.
you are being asked to find the value of a and b that are the part of a polynomial.
Yeah.
So there are three different ways of solving it. You can like pick any method you prefer. What's the method that comes to your mind?
First I find both the values of x and then I plug them each into different equations and then I simultaneously solve both the equations.
Right. And so you are basically going for middle term breaking of this quadratic factors,
Yeah.
right? Okay, that's
Yeah.
correct. That's one of the way. So I want you to do this, complete this, get the values of a and b, and then I'm
Yeah.
gonna introduce other method as well.
Okay, so I got them, I think. Is A minus 18 and B 4?
B should be minus 8. Sorry, for the first part there is only one method. For the second part there are two methods. Sorry.
Oh,
Yeah. So 3x squared plus 5x minus 2 can be simplified as 3x minus 1 and x plus 2. If you go for middle term breaking, that's what you get. You get two linear factors. So now if you apply the factor theorem, what you are going to get is that when you in the function, when you are going to plug in 1 upon 3, you're going to get 0 because you already know it's a factor. And
Hmm.
when you plug in minus 2, you are going to get 0. So f of 1 over 3 means 3 times 1 upon 3 square plus 5 times 1 upon 3 minus 2. Oh, my bad. The polynomial is 3x cubed plus 17x square plus a times x plus b, that is going to be 0, and 3 times minus 2 cube plus 17 times minus 2 square plus a times minus 2 plus b is going to be 0. Now please solve these two equations.
Uh, yeah, so I got 2 plus 1 upon 3a plus b.
2a for the first one.
Yeah, for the first one. 2
What do
plus
you
1.
get? 2a.
No, I got 1 upon 3a.
Just a second, let me solve this as well. The first term is going to be 1 upon 9. The second term is going to be 17 upon 9 plus a upon 3 plus b equals to 0. If you make the denominators common, you are going to get so 3a plus 9b equals to minus 18. If you take 3 common, this is what you are going to end up with. That's your first equation. A plus 3b equals to negative 6. Are you getting this equation?
So I'm getting 2 plus 1 upon 3a plus b equals to 0. But if I multiply it by 3, I'll get the same.
Okay. Now for the second equation, that's going to be negative 24 plus 68 negative 2a plus b equals to 0. So 2a minus b equals to 68, take away 24 is going to be 44. These are the two equations, and you need to solve them simultaneously and get the values of a and b.
Yeah. So I got b as 4 and a as minus 18.
B as 4 and a as minus 18. Achha.
Mm.
Let me check this from the calculator. So a 3 negative 6, 2 minus 1 44. I'm getting 18 and minus 8. Let me show you the working now. So from the first equation, a is going to be minus 6 minus 3b. 2 times minus 6 minus 3b minus b equals to 44. Minus 12 minus 6b minus b equals to 44. Minus 7b equals to 44. 7b is going to be negative 12 negative 44 divided by 7. Now you get b as minus 8. Therefore, a is going to be minus 6 times minus 3 times b, that is going to be 18.
Okay.
Let me know when you're done.
Yeah, I'm done, sir. I found my mistake.
Okay. Where was it?
So it was a mistake with the signs.
All right. Acha. Now, as far as the second part is concerned, see, you have the polynomial now. The polynomial, after finding the values of a and b, is going to be 3x cubed plus 17x squared plus 18x minus 8, right? And the question, second part says factorize the polynomial completely. So, if you want to factorize the polynomial, what you can do is you can either go for long division, okay, or you can use comparing method. You already have a factor, so and that's a quadratic factor. So if I am going to divide this polynomial by the quadratic factor, that was 3x squared plus 5x minus 2. Please divide this cubic polynomial by the quadratic factor. You are going to get the linear factor now. Are you getting x plus 4?
Yes, sir.
So 3x cubed plus 17x squared plus 18x minus 8 can be written as a product of 3x squared plus 5x minus 2, the divisor or the quadratic factor, times the quotient, that is x plus 4. Now we already have simplified this previously. 3x squared plus 5x minus 2 is same as saying 3x minus 1. 3x minus 1 times x minus 2 plus 2 plus 2, right? X plus 2 times x plus 4. So you see, you were able to express the cubic polynomial into its three linear factors. That was a question all about. You need to factorize this polynomial, and that's the factorization of the polynomial. Okay, so this was done using long division. Any questions still here?
No, sir.
Then the second method you can go for is equating coefficients. Obviously, you're going to pick one and go by that. So I know that 3x cubed plus 17x squared plus 18x minus 8 can be found by multiplying the quadratic factor 3x squared plus 5x minus 2 by any linear factor. So as far as the linear factor is concerned, I'm going to name it, let's say, cx plus d. Okay. Now you can, what you can do is you can just multiply them and equate the coefficient and find the value of c and d. You're still going to get the same thing. So the quick method to do this is 3x squared is going to multiply is going to get multiplied by cx to get you the term in x cube. That is going to be 3x 3c x cube. And over here, what is the coefficient of x cube?
One.
3x cube, right? So if you simplify everything, you're going to get c as 1.
Yeah.
Now, as far as the value of d is concerned, d, you can find d by equating the constant terms. So if you multiply minus 2 by d, okay,
You equated
you're going to
answer.
get a constant term that is minus 2d, and on the on the left hand side you have the constant term as minus 8. So if
Yeah.
you simplify this, you get d as 4. So cx plus d is same as saying x plus 4, and that was our third factor.
Yes, sir.
Okay, yeah.
Okay.
Now sometimes in the question you will not be given any factors and you will just be asked to solve a cubic polynomial. So solve this equation. So we don't have any factors. Now what you are going to do is you are going to go for trial and error method and you are going to find the factors. So let my polynomial be equal to x cubed plus 4x squared minus 19x plus 14. And what I'm going to do is I'm going to find the positive and negative factors of the last term. So the positive and the negative factors of 14 are going to be plus minus 1, plus minus 2, plus minus 7, and plus minus 14. Do you get this term concept?
Yes, sir.
Now I'm gonna just randomly plug in any of these. These are 8 factors with me, both positive and negative. I just want to get one factor that is going to give me the remainder 0 when that value is plugged in the function. So
Okay.
let's try out with 1, f of 1. What is f of 1 coming out?
0.
0. So if f of 1 gives you 0, then x minus 1 is a factor.
Factor.
If at minus 1 you were getting 0, then if f of minus 1 would result in 0, then x plus 1 would have been a factor. Okay?
Okay.
Alright. So once you know that x minus 1 is a factor, you can just go for long division again.
Yeah.
So x cubed plus 4x squared minus 19x plus 14 is being divided by x minus 1. Oh my bad, sorry. This is 5x squared. So when you are going to add 4x squared with x squared, you are going to get 5x squared minus 19x. This should be multiplied by 5x to get you 5x squared minus 5x This is going to give you minus 14x plus 14. X times minus 14 is going to give you minus 14x plus 14 and 0. So I need to solve, remember this. See? So once I know that the polynomial is now going to be x minus 1 times x square plus 5x minus 14.
Yeah.
Is there a possibility to simplify x square plus 5x minus 14 further?
Yeah.
Let's see that. Sometimes there might not be a possibility as well. If this was not a reducible quadratic equation, quadratic expression, then there's a possibility that you might not get the two linear factors. Okay, and sometimes it is going to factorize. In this case, it can factorize. So give me the two linear factors of x square plus 5x minus 14.
X minus 2 and x plus 7.
X minus 2 and x plus 7. Yes. So these are the three linear factors. But the question is not about factorizing, it is about solving. So solving means finding the roots, finding the solutions to the equations. Finding the
Yeah.
solution to the equation when this was equal to 0. So you are going to set p of x equals to 0. Therefore, x minus 1 is going to be equal to 0. So the value of x is going to be 1. X minus 2 is going to be equal to 0. So x equals to 2. And x equals to minus 7. These are the three solutions to this. Okay?
Okay.
All right. Should I move on?
Yes, sir.
Now we can look at remainder theorem. So in hello,
Hello?
yeah. So in remainder theorem, if you have a polynomial p of x and it is being divided by a, let's say, x minus c. The polynomial is divided by x minus c, and you get a quotient and you get a remainder. Okay, so x minus c is not going to be called a factor, it is going to be called a divisor. And if in the polynomial you plug in the value of c, so if you plug in c over here, this entire term is going to be 0, and the answer is going to be equal to the remainder. So this leads us to the remainder theorem, which says that if a polynomial p of x is divided by x minus c, the remainder is p of c. So whenever in the polynomial you are going to plug in the value of c, you are going to get the remainder. Similarly, if a polynomial p of x is divided by ax minus b, if it would have been a linear expression like this, the remainder is going to be p of b upon a. So whatever value you get after plugging b upon a in the polynomial, that is going to lead you to the remainder. Is this concept clear?
Yes, sir.
So find the remainder when 4x cube minus 2x square plus 5x minus 8 is divided by x plus 1.
Is it minus 19?
Yes. So I'm gonna plug in minus 1 over here and minus 4, minus 4, minus 2, minus 6, minus 5, minus 8, yeah, minus 19. That's correct. Okay, let's try this one out. The function given to you is 6x cubed plus ax squared plus bx minus 4. When the function is divided by x minus 1, the question says that the remainder is 3. And when the function is divided by 3x plus 2, the remainder is minus 2. You need to find the value of a and the value of b. Okay, please give this question a try. So what does the second equation simplifies to?
So I'm still stuck on that. I think it's 4 upon 9a minus 2 upon 3b equals to 39 upon 4.
Okay. Okay, let me simplify as well. So minus 2 divided by 3, the whole thing cube, times 6 is minus 16 upon 9 plus 4 upon 9a minus 2b upon 3 minus, I can take minus 4 on that side and make it plus 2 minus 6b equals to 8 is equals to 2. 4a minus 6b equals to 18 plus 16. So 18 plus 16 is 34. I can take 2 common out, and this is going to result in 2a minus 3b. 34 divided by 2 is 17. That is the second equation. Now you can solve this and this simultaneously to get me the value of a.
B is minus 3 and A is 4, I think.
B is minus 3 and a is 4. Okay. Yeah. So any doubts in remainder factor theorem and the division of polynomial?
No.
No. Okay. Just hold on a second. I need to just see if I can give you some questions to solve. Okay, I'm just giving you one question for practice. The polynomial 6x cubed plus x squared plus ax minus 10, where a is a constant, is denoted by p of x. It is given that when p of x is divided by x plus 2, the remainder is minus 12. Find the value of a and hence verify that 2x plus 1 is a factor of p of x. Part B is when a has this value, solve the equation p of x equals to 0. Okay, let me give you the answers as well. So answer to the first part is going to be a as negative 21, and to the second part is going to be minus 5 by 3 minus 1 upon 2 and 2. Okay.
Yeah.
So I have given you a worksheet. I have WhatsApp you some questions on modulus and this question.
Yeah.
Okay.
Okay.
All right. That's all for today. I'll see you in the next
Thank
class.
you.
Inshallah. You're welcome.
Okay.
Allah
Okay.
Hafiz.